Welcome to our 6th lecture in Computer Programming 2. In this lecture, we're going to take a look at casting, instance of, and overriding methods. Now, one question is, we have in our class called Prius. Let me click on that. We have some methods here, and what if we want to call them from driver? That becomes a bit of a tricky situation. And the reason is, those methods are only available on a Prius. If we take a look, we remember that we have some setters methods for miles per milliamp hour and battery charge that are only on Prius. But we're dealing with a variable of type car, which means it could have an object of type car, an object of type neon, an object of type cavalier, or an object of type Prius inside. The only one that's actually going to have those methods is going to be the Prius. So what we need to do is cast. And I have to warn you, casting is not good. We don't want to do this. We want to try to avoid this if possible. But needless to say, we do know that not everybody's going to go to a good program like UC's, and maybe somebody will design in a not optimal manner, and we have to be prepared for that. So what we do to cast is we say Prius, my Prius equals, and then the type we're casting to in parentheses, Prius, my car, okay? And now we can say my Prius dot set battery level, and let's say 15, okay? My Prius dot set miles per milliamp hour, and once again we can say 10, that's fine, okay? Let's set the battery level at, let's set it at 12, how about that? Okay, so take a look at this. We can call these methods specific to Prius only if we cast the generic type car to the more specific type Prius. Actually, let me put that a better way. The general type car to the more specific type Prius. And I'll put that in comments. If we cast the general type car to the more specific type Prius, we can invoke methods specific to the Prius. Recall that the variable type tells us which methods we are allowed to invoke. Okay? There we go. This works well if our object type is a Prius. It does not work well if our object type is not a Prius. So let me run the program. Actually, I'll debug it, and we'll watch what happens when we actually are holding a Prius, and then we'll watch what happens when we're not holding a Prius. So I F7 into prompt user. Again, I'm going to go through these a little faster than last time because we've already seen them before. I get my first pop-up. This time I'll create a Prius and choose OK. OK, F8. Create car, we'll F7 into that. We see that we're going to create a Prius and return that. Okay, what's the odometer reading? 10,000. Okay, F8, F8, F8. How many gallons of gas? 10. F8, F8, F8. How many miles per gallon? 50. F8, F8. Now, note here's the cast. Casting my car to a Prius type and then setting the battery level and the miles per milliamp hour. All works well. Got it? And now let's loop again. Yes, let's create another car, but let's see what happens this time when we create a neon and we try that same cast. F8, I'll go ahead and let's go through this a little quicker than normal. What's the odometer reading? 20,000. F8, F8, F8. How many gallons of gas? 20. F8, F8, F8. How many miles per gallon? 20. F8, F8. Okay, watch carefully here because we're going to get some behavior we're not going to like. When I choose F8, I'm trying to tell Java that the object in this myCar variable is actually a Prius, but it's not. It's a neon, and if I mouse over, we can see that in that yellow box, that the object type is actually a neon. We cannot cast an object to a more specific type unless we know for sure it is that more specific type. If we try to cast anyway, we'll get a class cast exception and the program will crash. So I choose F8, boom, program's dead. I'm going to go ahead and terminate it, and we should see, well, shoot, I was hoping to see an output. I didn't see what I wanted to see, but nonetheless, that kills the program. That kills the program. We have to make sure it actually is a Prius if we're going to do that cast. And one way to do that is to use a very interesting operator, comparison operator. It's the only comparison operator in Java that's not a set of symbols. Instead, it's two words put together. So I'm going to say, see if we have a Prius under the covers. If my car instance of Prius. Instance of says, look under the covers of this object and tell me if it's a Prius. Okay, instance of is all one word, lowercase. It's not a method. Don't be confused. It's not a method. Okay, a lot of people say my car dot instance of open paren Prius close paren. No, it can't do that. It is a comparison operator. It's comparing the object and the variable on the left with the type on the right, returning true if they're the same, false if not. It's not a method. It's a comparison operator, just like less than, greater than, equal to, not equal to. It's the only comparison operator in Java that's a word, not a symbol. So I start my open curly here, and within this if, I want to put everything that is specific to that Prius type. So I start my open curly on 64. I do all the Prius specific stuff on 69 through 71. And then I do Alt-Shift-F to auto-indent because this is a new block. And there we have it. Okay, and then I save. Okay, so that is the instance of operator and casting. Two pretty ugly things in object-oriented programming. So try to find another way around it. Try to avoid this. But that being said, if you have to use this on your programming assignment, that's perfectly fine with me. So in real life, try to avoid it. But if you use this on your programming assignment, I'm not going to deduct points if you do it properly. Because it is usable. It's just not good design. That's all. So there we go. Now, let me go into Prius and let's think about overriding methods. We know in car that if we travel a given distance, the odometer is going to increase and the gasoline used is going to decrease. Is that always the case in a Prius? No, not necessarily. The odometer will increase, but if we're running on the car's battery, the gallons of gas will not change. What we want to do is override this method and give it specific behavior. And by the way, do not confuse override and overload. Overload we covered last quarter. They're two different things. Overload means same method name, different parameter variable list. Those two can be in the same class. Two methods, two or more methods with the same method name in a different parameter list. J-option pane show input dialog is a great example of that. Override specifically happens when we have superclass and subclass. And it means that a subclass inherits a method, but then has a method with an identical signature that overrides that method. Okay? And so what I'm going to do is I'm going to take this go method signature straight out of car. I'm going to copy it and I'm going to paste it into Prius. Okay? And close curly. There we go. And now Prius is overwriting the method go from the superclass. This is very important. This is a very important concept in object-oriented programming, the concept of overwriting. What we can do here is we can decide whether to run with electricity or whether to run with gas. So I'll make a constant here. We'll say public static final battery threshold. And that means at what point does the battery get too low when I go and use the gas engine? Let's say battery threshold equals, let's go ahead and say 10. Okay, so when the battery charge, I'm sorry, public static final int, battery threshold equals 10. So that means if the battery charge goes below 10, I'm going to use the internal combustion engine. Okay. Now in my go method, what I can do is I can say decide whether to use the battery or the internal combustion engine. Okay. If battery level, you know what? Yeah, okay. Because we actually set those. Okay. If battery level less than battery threshold, okay. Use the internal combustion engine. Else, okay, use the battery. Okay, let's actually do this computation first, because this is the one that's specific to the Prius. We're still going to increase the odometer. Okay, odometer plus equals distance. Okay, compute the charge used. Okay, so we'll say int, or let's say, I really should make that a double. Oh well. Int charge used equals distance divided by miles per milliamp hour, just like miles per gallon. Okay. Subtract the charge used from the battery. Okay. Battery level equals battery level minus charge, whoops, sorry, minus charge used. There we go. Okay, slight misspelling there. Okay, so simply use the battery. There we go. Okay, now for if we're going to use the internal combustion engine, I can go to driver, I'm sorry, I can go to car, and I can simply copy the existing logic, and no change here, and paste it into the first part of the if test. The one thing we will do is we will probably, well, first I'll Alt-Shift F to auto tab. We also want to remember if we are running with gas, we're recharging the battery at the same time. So let's have a recharge factor, public static final int recharge factor equals, what this means is for every, let's say 20 miles, we recharge the battery by 1 milliamp hour. Okay, so we'll say here under go, we'll say recharge the battery. Okay, so we'll say int increased battery charge equals distance divided by, oh, I misspelled recharge too. Distance divided by recharge factor. So at a recharge factor of 20, if we go 100 miles, we're going to recharge the battery by 5 milliamp hours. So we'll want to add that to our battery level. Battery level equals battery level plus increased battery charge. In other words, when we're running with the internal combustion engine, what's going to happen is as we brake the car, it's going to recharge the battery. As the alternator runs, it's going to recharge the battery. Certain things while we're running with gas will recharge the battery, and we want to factor that in. Beyond that, everything else is the same. Now, you know what else would be nice? Believe it or not, our go method is now complete. It would be nice if we could see this output when we do a two-string. And guess what? We have our two-string method up here in car. We can override that in Prius. So I'll copy it from car. I'll paste it into Prius. And we'll add, after gallons of gas, we'll add plus battery charge. Okay, plus battery charge. So for Prius, it's also going to say the battery level. Did I misspell that again? Or battery level, yeah, we'll say battery level plus battery level. Okay. Now, let's take a look. When I run this class, when I run this program, let's see what happens when I tell the Prius to go. I'll make a couple of changes here. First of all, I'm going to run the car twice for 100 miles so that we can see the Prius toggle between hybrid mode or between electric mode and gas mode. So we'll actually run each car 100 miles to and another 100 miles from. So what I might want to do on the Prius then, yeah, battery level is 12, miles per milliamp hour is 10. If I run 100 miles, that's going to take 12 down to 7, which is going to take us below our threshold. Then we'll switch over and use the gas engine on the way back. That'll work. I just want to make sure that the numbers work. Yeah, I think those numbers should work for us. Okay, lots of stuff going on here. So let's watch closely in the debugger and see what's going to happen when I run this program. Let's watch when that go method will be called. I'm going to right click now and make sure I save everything first. Right click and choose debug file. F7 to step into the method. F8 to do my first prompt. And for this, we'll go ahead and do neon for the first one. That'll also validate that our instance of method works properly. F8, F8, F8. What's the odometer reading? 10,000 on our neon. F8, F8, F8. What's how many gallons of gas? 10 for the neon. F8, F8, F8. How many miles per gallon? We'll say 20. We'll say 20 for the neon. F8, F8. Okay, is it a Prius? No, it's not. So it's going to skip this if test and move to the line immediately after the if test. There we go. Add it to the collection of cars. Loop again. Do you wish to enter more cars? Yeah, this time around, we'll enter a Prius. Okay, select a car from below, Prius, and OK. F8, F8. What's the odometer reading on our Prius? We'll say 20,000. F8, F8, F8. How many gallons of gas? We'll say, actually, we can just say like 12. Okay, F8, F8, F8. How many miles per gallon? Let's say 50. F8, F8. Is it a Prius? Because we chose Prius, the object under the covers is a Prius. And this if test should evaluate to true, which means we'll go into this little routine where we enter the miles per milliamp hour. There we go. We could prompt for that as well. Add it to all cars. That's enough to demonstrate what I want. So I'm going to change this to no more cars to enter. Now we get to the big puzzle. F8. Let's print the cars. F7. Okay, our first car is going to be the neon. Okay, let me pull up here so we can look at the variable types. Our first car is going to be the neon. I choose F8. Okay, let's see if I can go up a little bit more. Notice in the debugger that the type here is neon. Okay, I choose F8, and now I'm going to choose F7 on this go method. And watch where it's going to take us. I choose F7, and where are we? Look at the tab that's lit up. It's car. Okay, since a neon inherits the go method, when we invoke go on a neon object, it's going to take us to the go method in car. So F8, F8, F8. F8 takes us back to driver. Print the state after the first trip. Do the second trip. I'll choose F8 to go ahead and run that. Print the state after the second trip. Now, our second time around the loop, the object type is Prius, and that's what's represented in this type column. It's the object type. So our second time around, the object type is Prius. Now, here's a puzzle. We'll go ahead and execute this first line. When I choose F7, where's it going to go? Is it going to go into car and invoke this method? Or is it going to go to Prius and invoke the identical method signature, but in the more specific class, Prius? Okay, and here's where it gets confusing. What is our variable type here? What is car defined as? Car is defined as the general type car. But what's the object type that's actually in that variable? Prius. So think to yourself, When I choose F7, is it going to step into the go method of car or the go method of Prius? There's one way to find out, and that is to choose F7. It steps into the go method of Prius. And this is where I say the variable type tells us what methods we are allowed to call. The object type tells us what behavior to get when we call those methods. In other words, the variable type car says there is a method called go that we can invoke. But when we invoke it on an object of type Prius, we're actually going to get the code and the logic that's in the go method of Prius. And now let's see, battery level is 12, the battery threshold is 10. We have enough battery juice to run, so I choose F8. Okay, increase the odometer, figure out how much charge we used. We used 10 units, 10 milliamp hours. Decrease the battery level by that amount, and then return. And now we're back in driver. Now we're going to do the return trip, and once again, we still have a Prius object. A Prius object stored in a variable of the supertype car. Once again, on that Prius, I'm going to choose F7 to step into the go method. And this time, because I'm doing the return trip, what's my battery level? 2, very low. What's the threshold? 10. If 2 is less than 10, then we need to run on the internal combustion engine and recharge the battery. So I choose F8, and no surprise here, it does the logic we copied in from driver, and then it does a little bit of math to increase the battery level, and then we're all set. Okay, and we print our final output. Let's take a look at that output. Okay, take a look. We run the neon, 10,000, 10,100, 10,200. Gallons of gas, 1050. Now, notice that when we run the Prius, we also get the battery level, and that's because we're overriding the method called toString. Believe it or not, you've been overriding a method called toString all quarter long, and you didn't even know it. Why is that? Because there is a superclass, and I'm going to go ahead and finish up the debugger here. There is a superclass called object that all classes extend from, and I absolutely hate that name. I hate that there is a class called object because that really confuses things. Let's just call it Big O. There's a class called Big O, and all classes at some point, that is the Adam and Eve class. All classes will eventually extend from Big O. And one of the things, or I'm sorry, capital O. There's actually something else called Big O. So all classes have in their ancestry the class capital O object, capital O. We'll just call it capital O. Now, this class called capital O object, let's look up the Java doc on it. It's in package java.lang, java.lang.object. I cannot believe they called it that. Here we go. And we'll see that capital O has all of these methods defined. Clone equals finalize get class hashcode notify all toString wait. Here's toString. The only directions here are it returns a string representation of the object. Public string toString is the signature. Okay? Public string toString is the signature. We've been overriding this all along. In our car, where we have toString, we're actually overriding that method. Now, why do I bring that up? First of all, if you ever notice this yellow line, it says we should add the @override annotation, which tells us we're overriding a method. That's a good idea. I'm going to go ahead and do it. Okay? I should really do that in Prius as well. Here on this toString, add the override annotation. And here on the go method, add the override annotation. That way, if the superclass method ever changes, we'll know about it at compile time. I know that sounds really weird and out there, but I can tell you that I worked on an upgrade project, and people who used @override saved me a lot of time. People who didn't wasted a lot of my time. So it might seem very trivial now, but it actually is very important. Okay. Now, why do I say that? The reason I say that is that anytime Java needs to take an object and get a string representation, it automatically calls toString. So, as a matter of fact, this is redundant. This line 86 is redundant because we have a string to the left of a plus. And remember what it is when we have the string on one side of a plus? It turns that plus into the concatenation operator. So if we have a string on the left and an object on the right, Java will automatically call the toString method. We don't need to specify that here, and I can remove it. And it will all work as it has before, just like that. So if Java needs a string representation of an object, it knows it can call toString. And why does it know it can call toString? Because every Java class in the world at some point extends from capital O. Capital O has this signature toString, which means every Java class either inherits the method or can override the method. So you can always call toString. There we go. One other thing that's important to notice is there's an important rule in programming, which is do not repeat yourself. And I have violated that rule. I did copy paste, which is a no-no. I copied the go method here and pasted it into the Prius here, just these lines here. We shouldn't do that because now we have duplication redundancy, and this will dramatically increase our bugs and our time and cost to maintain a program in the long run. So what if I am in the overridden method and I want to call the superclass method? What I can do is remove this and call super.go distance. The super keyword means, okay, I'm overriding a method. I want to call that method and reuse that logic. The super method says, find the actual superclass method and invoke that. And that's what we're doing here. Okay? Again, that's going to be really confusing until we use the debugger. And I will tell you with no reservation that if you have not gotten used to the debugger yet, you're really going to want to invest some time in learning it before you do programming assignment number 2. Because if you don't, you will be super confused, turn it in late, and not understand it. If you use the debugger, you'll be able to walk through it step by step and do that frequently. Walk through it frequently. And you'll have a much better understanding and a much better chance of finishing the program on time. So I save, I go back to driver, and now specifically we're going to look at a Prius. Specifically, we're going to look at what the Prius does. Okay, I right click and choose debug. Okay, F7 to step in, F8, F8, F8 for our first prompt. By the way, there's that big O I was talking about, the capital O object. I don't like that word because it's confusing. It's not the same thing as other objects we talk about. But in any case, get my prompt, and here I'm going to say Prius and choose OK. Okay, we're going to F7, step in and watch us create an object of type Prius. Okay, after we create the object, we're going to populate it. Odometer 10,000. Gallons of gas 10. Miles per gallon 50. Okay, if it's a Prius, we set these items, add it. Again, we're going to focus on the Prius. We've seen the others run. I'm going to choose no, okay, so that we can go ahead and watch this. Now I'm going to go to print cars. And once again, if I'm on a method call like this, if I choose F8, it will run the method and just take me to the next line. If I choose F7, which I'm going to choose, I can step into the method and watch it work. Okay, F8. Just out of curiosity, I'm going to choose F7 here. Okay, one moment. Shoot. Okay, I was hoping to step into the toString method, but trust me, the toString method was invoked on that car. As a matter of fact, I can set, I'll tell you what I can do to make that break there, is I can go into Prius and I can set a breakpoint on toString, and we'll see that hit when we do that system out print line. So I'll show it this time. Okay, car.go, I'm going to choose F7. Remember, under the covers, the object type is a Prius. Prius overrides the go method of the superclass car. So when I choose F7, it's going to take me to the overridden method in Prius. And also remember, on our first trip, we have enough battery juice to run on the battery engine. So I F8, go to the else part, just like last time we ran. F8 to take me back to driver. Now, this is where I have a breakpoint set in the toString method. Remember again, the plus operator. If it sees a string on one side, it's going to turn the other side into a string as well. And it's going to do that by invoking toString on this variable car here. So I choose F8, and there we go. Notice it's invoking toString in Prius. F8, F8. Okay, F8. Now, the go method the second time around, after we've taken the battery down to a dangerously low level, we have to use the internal combustion engine. So I'm going to press F7, and I want you to pay close attention to the tabs on the top of your screen. I choose F7, and I choose here F8. Now notice we're in Prius, but I'm calling super.go with the same signature as this go method here. Watch what happens when I choose F7. I'm in Prius. I'm going to hit F7 on super.go, and watch what happens to these tabs. I'm going back to car because I said I want to reuse that method from car. And sure enough, we reuse those computations in car. Okay, and there we go. And then when it returns us back to Prius again. We finish up this method, and we print the output, boom, boom, and we're all done. And I terminate the debugger. So there we go, and I think I terminated it too quickly. Oh no, there we go, we can't see the output. So we see car before running, this is our Prius, 10,000, 10 on the gallons of gas, 12 on the battery. After running, the first trip, 10,100. The gallons of gas did not change because we were using the battery. Battery level did change. After the second trip, odometer is now 10,200. Gallons of gas decreased by the 2 gallons we've used, and the battery charge has increased because while running on the internal combustion engine, we increased the battery. We recharged the battery. So important things from this lecture include instance of, casting, and this idea of polymorphism and dynamic binding. For more information on polymorphism and dynamic binding, go to my webpage, Inheritance, and there's a slide here on polymorphism. Okay, and a slide on dynamic binding, which basically goes through what I've been explaining to you. Okay, polymorphism and dynamic binding. It's a tricky concept, but very, very important. Okay, I strongly recommend you watch this lecture again. I know we're on 33 minutes, but especially if you were distracted, if the dog came up and wanted you to pet, and maybe you just glossed over a few minutes, this is very important. If you understand this lecture, you'll be well set for the big exercise that's going to happen where some people get it and other people won't. If you don't understand this lecture, it's going to be very confusing. So this lecture is very important. Consider replaying it. Also, of course, I'll post what I've done on Blackboard so that you can walk through it in the debugger as well. And I strongly recommend that you do. Okay, so car is what I did. It's like your account. Neon is like savings. Cavalier is like certificate of deposit. And Prius is like checking, because Prius overrides the go method. Checking is going to have to override the calculate method because it's going to have to take into account the monthly maintenance fee. So where Prius has overridden the go method from car, checking is going to have to override the calculate method from account. So you see, this programming assignment models very closely programming assignment number 2. Don't get me wrong, programming assignment number 2 is going to be a little bit challenging, so you probably want to start on it as soon as you can. Okay, I'll wrap up this lecture. Our next lecture we'll talk about abstract classes, but this is everything you need to know for programming assignment number 2. So I'm going to go ahead and wrap up this lecture and post it and send out an announcement. And don't forget quiz question suggestions. I will probably put up 2 different quiz question suggestions to cover this lecture and the ones that preceded it. Because this information is very important, we have to practice it several times. Thank you.